Hi everyone, welcome back to Calculus with Jackie and Shadow. Today we're going to be talking about finding limits using a special tool called the squeeze theorem. Now, if you think about the squeeze theorem, it's basically if you have two functions, let's say you have f of x and g of x, or if you have you could think of it like the positions of Jackie and Shadow. But basically, if you have two functions and then a third function that goes in between them, that function will always stay in between them. So if the two outer functions ever approach each other, the inner function will approach that common value. So the, if you're taking a limit, the limit of f of x is the same as the limit of g of x for some value of x. Any function that stays in between f of x and g of x will have that same thing. You can see it on this graph. Let's try to draw a third function. It can make it so that it goes up and down, but it can't leave the functions like that. Like it can't go outside of them. It has to stay in between them. And you can make it go back and forth. But you'll notice that it's getting compressed down, like it's getting squeezed. That's why you call it the squeeze theorem. You're squeezing this third function in between the two other functions. And let's look at an example problem. You can do this with algebra or a graph. So an example is Spirit's flight lesson. We're going to have Jackie flying on the x and y axis with the equation y equals x plus 6. So it's going to be sort of a straight line. And then Shadow flying on the x and y axis with negative x squared plus 5x minus 2. Now Spirit is learning to fly, so she's going to fly right in between them at all times. And what y value is Spirit going to approach as x approaches 2? Well, let's think about this. So Jackie is going to be flying like that. And as you get closer and closer to 2 with x plus 6, it's getting closer to 2 plus 6, which is 8. So you can do direct substitution there. And then negative x squared plus 5x plus 2, that's 10 minus 4 plus 2, that's also going to be 8. So they're both going to be approaching y equals 8, like that. They're getting closer and closer. So Spirit is going to be going right in between them and staying close to y equals 8 when x is near 2. And we can look at a graph of this. If you have j of x and s of x, they're approaching each other. This is, if you scroll down, these functions are what the value of j of x and s of x are. And if you zoom in right on here, you can see that they're both getting close to 8. And if Spirit is going to be flying somewhere in the space in between, her y value is also going to get close to 8. Now, a cool application of the squeeze theorem is it allows us to actually prove that the limit as x approaches 0 of sine of x over x does in fact equal 1. So to prove this, we're going to look at the unit circle. And we have sine of x represented by this line right here and cosine of x. And it's going to form this triangle. Now the area of the triangle is sine of x times cosine of x over 2. And that's going to be our function that we're squeezing in between two other functions. Now, what are their other functions going to be? Well, one of them is just going to be x, because the area of this arc is 1/2 x. It's x 1/2 xr squared for the area of a circular arc where x is the angle measured in radians. And since the radius is just 1 on the unit circle, it's going to be 1/2 x. And this contains the triangle, so we know that this is going to be bigger than the triangle. And then if we look at this inner circular arc, it gives us the same thing, but in this case, the radius is cosine of x. So it's going to be 1/2 x cosine squared x. Now, if we hop over to the graph, we can look at our inequality here. So you have 1/2 x cosine squared x is less than 1/2 sine of x cosine x, which is less than 1/2 of x. Now, the first thing we can do is just get rid of these 1/2s. So now we have this inequality. And now to get something that looks a little bit better, because we want to get sine of x over x. That's what we want to find the limit of. So to do that, we divide by x cosine x. So we're going to divide to get sine of x over x. And this turns into cosine x. And this turns into 1 over cosine x. And that gives us our final inequality. Now we can see that cosine of x approaches 1 as x gets closer to 0 because cosine of 0 is 1. And that's the same with 1 over cosine x because we have 1 over a number that's really close to 1. So that means both of these approach 1, and by the squeeze theorem, sine of x over x is going to be squeezed in between these two functions, and it's going to end up, the limit's going to equal 1. So that was probably kind of hard to understand. But that's it for today, and I'll see you again next time.